So good afternoon all. This week's tutorial is basically based on Z transform. So I hope all of you are familiar with Z transform from your 3 to 3 unit, right? So it shouldn't take us that much time, but again, like usual, just in case if it takes more than 40 minutes, this session will end. You'll have to rejoin using the same link again, right? The other thing is please make sure your username, right, or your participant name is, your participant name is both your name and ID, right? So that's the usual process. So let's start. Question number 1, we need to find the Z transform of this particular sequence that is given, right? 3.1, right? A and B both, we have to find the Z transform of these signals. So either you can evaluate it using the Z transform definition, or you can directly Z transform it, right? So we know that 6 is the x of 0 point, right? So 3 is 5 units shifted to your left, isn't it? So that would give me a Z transform of 3 Z to the power of 5. This 5 indicates 5 places shifted, or 5 units shifted to your left, right? Isn't it? So just recapping on your basics, right? So 3 Z to the power of 5 plus all are zeros. So basically these terms are null, right? You don't need to write it down. For 6, right, that will be 6 Z to the power of 0. So that is just 6 plus next is 1, right? Plus 1 Z to the power of minus 1, because it's 1 unit to your right, right? So plus, we can either write 1 or we can leave 1, right? So either way, plus 1 Z to the power of minus 1, right? Next term is minus 4. So minus 4, again, it's 2 units to your right. So Z to the power of minus 2, right? The region of convergence for this particular term is, just before I tell you, the ROC is defined as the values of Z for which the sequence is finite value, right? Has a finite value. So just looking at this, you can see that if Z is equal to infinity, right? So this particular term would give us an infinite value. So it won't be defined, right? It won't be finite. So that is why definitely infinite is just like an infinite value. So all the values will be less than the infinite value, isn't it? So Z is less than infinite, right? So next thing is that we can see from this particular point, Z to the power of -1. So when Z is equal to 0, right, this and this term will give me infinite value, isn't it? Or undefined. The system will be undefined. So again, in this particular term, we have to avoid 0. So absolute of Z is greater than 0 and smaller than infinity. So that is why ROC for this particular term, right? Then B, we need to evaluate the Z transform of these two particular terms, right? Again, we can use our Z transform property. So it has been shifted 5 units to the right, right? And directly 1 upon 1 minus half Z minus Z to the power of -1. That is using the Z transform property, right? So that is what we get. So just using the definition, we get this particular part, right? Direct substitution, and our n starts from n is equal to 5 and goes up till infinity for this particular part, while the rest of the values are 0. So that is why my lower limit is 5 and it is greater than or equal to 5. So my upper limit is infinity, while for n is equal to 4 and lesser values, that is up till summation from -infinity to 4 is going to be 0, right? So directly substituting the values, will be ending up with this particular part, right? Or you can use the definition. I mean, you can directly use the transformation values, right? So you'll be ending up with this. Again, to determine this region of convergence, so in this particular term, what we do is this whole equation will be governed by the poles of it, isn't it? So if the sequence by chance tends to 0, the lower part, the denominator part gives me 0, the function will become undefined, or it will be an infinite value. Or here, when we divide by 0, it is undefined, isn't it? So it will give me a unbounded system in that particular case. So what we do is we find the modulus of these that is greater than equal to, greater than 0. So by doing that, we can see if we solve for 1 minus half z to the power of -1, the absolute value is greater than of 0. We can solve that, and we can see that absolute of z is greater than half, right? So in that particular case, that becomes my region of convergence, right? Again, it is displayed like this, right? So that is one of the techniques. So basically just solve for the denominator, and it has to be greater than 0. In that particular case, this is the absolute value of this particular part. Okay. 3.3, 3.38, x1 of n is given as 1/3 to the power of n for n is greater than or equal to 0, and 1/2, right? That is half to the power of -n for n is less than 0. Again, just directly using the definition. Over here, the solutions were given in definition form. Again, you can use the properties or you can use the definition. It's either way around. Let's see what the question says. Question says to determine the Z transform and sketch the ROC of the following signals, right? Again, it does not say whether to use the definition or use the Z transform properties. So it's totally up to you. So in this particular case, you can see we can split this particular part into n is summation starts from 0 till positive infinity for 1/3 to the power of n, while summation for this particular part would start from -1 because 0 is included for the upper sequence, isn't it? Or for this particular part. So it will start from -1 and it will be summed until n is equal to -infinity, right? So that's how we get just direct substitution into this into this definition, right? And then splitting it up will give me these particular terms. Again, solving for these terms will just end up giving me this particular part, right? 1/1 minus 1, 1/3z plus z/2/1 minus z/2, right? Which can be further simplified as 5.6 whole thing upon 1, right? This whole term over here. Again, like I have earlier stated, these two equations are governed. The region of convergence is governed by the poles of this particular term. So again, absolute values of these, right? Either of these two terms cannot turn to 0. Otherwise, this whole sequence will turn, or this whole sequence will be undefined in this particular term. Again, the absolute of this value has to be greater than 0. And the absolute of this term has to be greater than 0. If you solve for these two, you'll see that you'll end up with the absolute of z for this particular term, right? Absolute of z is smaller than 2. While if you solve for this, you'll see that absolute of z is greater than 1/3. So that is how you get this particular term, right? Like I said, it has to be greater than 0. So this is how you get this particular term, or the region of convergence of this this region of convergence of Z transform of x1 of n, right? B x2 of n is equal to, right, 1/3 to the power of n minus 2 to the power of n for n is greater than or equal to 0. Otherwise 0 for n is less than 0. So basically it's a unilateral, you can just perform a unilateral Z transform in this particular case. So again, evaluating this, so the summation will start from 0 because other terms are 0, right? So summations start from 0 till infinity for this particular term only. So x2 of n is given by 1/3, right? Again, this particular term, just direct substitution, z to the power of -n. And evaluating term will give me, right? Evaluating all these will give me 1/1 minus 1/3 z to the power of -1 minus 1/1 minus 2 z to the power of -1, which is equal to this particular term over here, Again, to find the region of convergence for this particular case will be governed by the absolute values of these two particular terms. So you can see from this particular term, your z, the absolute of z is actually greater than 1/3, and from this, my absolute of z is greater than 2, right? Isn't it? Right. So we have two definitions for z. So in both the cases, one is z is greater than one term defines me z is greater than 1/3. The other term gives me that z is greater than 2. So in this particular case, for this particular term, we cannot have z is less than 2. While for this one, we can have any values that as long as it is greater than 1/3. So this one of the region of convergence will now be only governed by this term, right? Because this term tells me that z has to be greater than 2. So that is why the overall z, the region of convergence is just absolute of z that is greater than 2, right? 3.3 states determine the z transform. I mean, wait, 3.3c. Okay, yeah, we are again on the same thing. We just need to perform the z transform of x of 3 of n, which is equal to x1 of n plus 4. This is basically shifting the graph or the sequence 4 units towards your left, right? Okay. So again, from directly from this, I'm using the z transform. It's shifting of 4 units, so it will be it can be represented in z domain by z to the power of 4 multiplied by x1 of z, right? While the z transform of this will be just x3 of z. So in this particular case, we can see the region of convergence will be just governed by x1 of z. Whatever region of convergence we get for x of 1, right, of z will be the region of convergence for x3 of z, because this z upon 4 will not have any influence on the region of convergence of this particular term, right, the overall term. So basically the region of convergence of x1 of z is given by 1 upon 3, which is less than which is less than absolute of z, which is less than 2, right? So this is the region of convergence for x1 of z, right? That becomes the region of convergence for x of 3, right? x3 of z, right? So the overall equation on x3 of z will be given by just x1 of z directly multiplied by z to the power of 4. Right? So this has been already evaluated in 3.3a. We can see that we have already evaluated x1 of z or z transform by x1 of n. Right? So we have already evaluated for x1 of z. So we just need to multiply by z of 4, right? So this is what we get, right? 3.3d x4 of n is equal to x1 of negative n. So basically in this particular term, what it states is that the sequence is inverse, isn't it? So basically using the z transform properties, if it's a if it's a reflection across the this is the reflection across the y-axis, isn't it? So this is what we get. So using the z transform properties, we know that x of 4 z is equal to x1 of z to the power of -1, right? This is basically the time reversal property. Using this, we have already identified x1 of z that is given by 5.6 holding upon 1 minus 1/3 z -1 times 1 minus half z, right? This particular time omitting z to the power of 4 will just give me x1 of z. So what we just need to do in this particular term is, in place of z, we substitute z to the power of -1. right? So we end up with 5.6 holding upon 1 minus 1/3 z into 1 minus half z to the power of -1, right? Again, the region of convergence for this particular term will now be just finding the region of convergence for this particular term and region of convergence for this particular term. So if you solve for this, the absolute or the modulus of this particular term has to be greater than 0, right? To avoid this whole term turning into an undefined sequence, isn't it? For this sequence to be finite, this has to, the modulus of this particular term has to be greater than 0. Same goes for this particular term. So if you solve for this, right, 1 minus 1/3 of z has to be greater than 0. So absolute of that value will give me, you'll be ending up with z, right? The modulus of z is less than 3. Okay, so the same goes for this one. You'll be ending up with z is greater than half. So that combining those, combining the region of convergence of these two terms will give me half is less than z and z is less than 3. So that is the region of convergence for D. Oh, basically what you can see is that this particular term, I mean the region of convergence of Z1, I mean Z transform of X1 of n can be reversed, right? Basically you can reverse these signs. So 1/3 inverse of this is going to give me 3. 3 is inverse of smaller than sign will be bigger than, and z will remain as it is, while 2 inverse of this is going to give me half, while the inverse of this is greater than this, right? So either way, you can use whatever you find it easy, but I would just suggest to go by the equations, right, in order to find the region of convergence. 3.5, right? Question number 3.5 states to determine the regions of convergence of the right-sided, left-sided, and finite duration two-sided sequences. Again, going back to the properties in your textbook, this is the properties that we'll be using in order to define this, right? You can look up for the detailed evaluation of the formulas, but for this tutorial, we'll be just using this as a reference in order to define, what do you say, the question that is given. The question was, at 3.5, the question is determine the region of convergence of two-sided, left-sided. Okay, basically we need to define the region of convergence for an infinite and finite sequence, right? So 155, let's go back to 155. Okay, for this, let the two-sided sequence x of n have its transform with the region of convergence of R4, right? So, oh, sorry, with region of convergence as R1 is less than absolute of z or modulus of z, which is less than R2, right? R2 are the radiuses, right? Where R1 and R2 are greater than equal to 0, right? This is just a condition that you have to assume that the right-sided sequence, right? Right-sided, this R and L denotes the right-sided and left-sided sequence, be equal to x of n if n is greater than equal to n naught, or 0 otherwise. For the left-sided sequence, x of n if n is less than equal to n naught, right? Or 0 otherwise. So if you assume that your n naught is equal to 0, right? If you assume if your n naught is equal to 0, you'll be ending up with this particular sequence, isn't it? If your n naught is greater than 0, a finite sequence will be something like this. Okay, it is just on the positive half of the x-axis, right? While when n is, when n naught is equal to 0 and n is less than that, so in that particular case, our sequence will be something like this, right? It will be falling on the left-hand side of the plane, right? So let's assume that it's not n not to be of any value, not necessarily equal to 0. So that is why we have condition n is greater than equal to n naught, right? N naught could be 0 or any other value, right? Same goes for this particular left-hand side sequence, right? So this defines the right hand and the left-hand sequence, right? Now we need to define the region of convergence of the two and the combined region of convergence of both, right? So writing this down, if n naught is greater than equal to 0, right? Any other value. Remember, like I said, if you use this, right, causal sequence, or the, what do you say, if the sequence is of a, it could be any side, right? As long as it falls on the positive side. So rather than n naught, your sequence could start from here, or it can also start from here, as long as it falls on the right hand side of the plane. So that n naught, right? That is why we are considering this. If n naught is greater than equal to 0, so basically n naught could be any value as long as it is greater than 0. Then the right hand sequence would be summation from infinity to negative infinity of right hand x of r of n, right hand sequence of x of n multiplied by z to the power of negative n, right? Which is basically equal, right? This reduces down because the other half will be equal to 0, isn't it? Any value less than n naught, right? Any value less than n naught is going to be 0, right? 0 otherwise. If n is greater than equal to n naught, so n naught is my lower limit, right? N is equal to n naught, while n continues, n could be any value up till infinity, isn't it? So that is why my limits are n is equal to n naught and infinity, x of n, z to the power of negative infinity, I mean negative n, right? So based on these, if so this is basically the sequence that we get, right? So based on this, we know that the region of convergence for this particular part, right, is going to be will be falling on the outside of a circle of radius r, right, r1. So that is why absolute of z is greater than r1, right? You can see that that is same for this particular case as well, right? If it falls on the left hand side and the sequence is infinite, isn't it? It starts from n and it has no limit, right? It keeps on going up till infinity. So if that's the case, if the sequence is infinity, so we'll have an infinite duration signal, right? This is the infinite duration signal. So we'll be having something like this for the region of convergence. So in this particular case, we assume that the radius of r, this particular part, is equal to r1, some value of r1. So the modulus of z is greater than r1, right? In that particular case. Now, what if n is less than n naught is less than 0, right? Let's say what happens if this sequence shifts this side, right? Starts from somewhere here and continues to z transform in that particular case, right? Rather than starting at 0 or on any other point on the right hand side of the sequence starts on the left hand side at some value of n naught, right? In that particular case, if n naught is less than n, then the right hand sequence, the z transform of the right hand sequence will be equal to again the same sequence. So it starts from some n is equal to n naught, right? And the upper limit is negative infinity. The only difference is now the n naught value is less than 0, right? So this should have been n naught is less than 0, right? So there is a correction in this particular solution, right? This particular part has to be 0, right? What happens if n naught is less than 0, right? So in that particular case, we have this particular sequence, and now we can break it down. So from n is equal to 0 till positive infinity, the sequences remain as it is, right? Plus summation, it will start, since 0 is included of a, it will start from, this sequence will have an upper limit of -1, and it will continue up till n is equal to n naught, right? In that particular case. So basically, this sequence, this defines that, let's say our sequence starts somewhere over here, right? If n naught is less than 0. So in that particular case, the sequence is something like this. In order to determine the z transform of it, the z transform is easily defined for n is equal to 0 and continues up till positive infinity, it is directly given by this particular term, while we need to evaluate the z transform from here to here. So from -1, because 0 is already included in this the first term. So from -1, it goes up to n naught, right? So that is why my limit starts from -1 and it will go up till n is equal to n naught. So that is my z transform, the right hand z transform of this particular sequence, right? So based on this, again, similar to this case, right? If n is greater than equal to 0, if n is greater than equal to 0, right? And if it will give me a similar sequence to, okay, it will give me a similar sequence to this, right? Isn't it? Again, based on this, if we have something like this, it is the absolute of z is greater than, or it falls on the values of z has to be greater than the radius r2, isn't it? So in that particular case, the region of convergence for this will be absolute of z is greater than r1, right? And the region of convergence for this particular part, right? This particular part, it is definite, right? It's not infinite. It is definite. Like I showed you the sequence, this is definite. It is a defined sequence, or it is a finite sequence, right? If the sequence is finite, and it is an anti-causal sequence, or starts or falls on the sequence falls on your left hand side, so we use the properties over here. In this particular case, z is absolutely equal to okay, z infinity, right? Less than infinity. So in that particular case, pardon me. Okay, z has everything inside this particular plane, isn't it? That includes the 0 part, but z is not, or z does not include infinity, isn't it? So the limit for this would be z is less than infinite. So that is why the region of convergence for this, it is a defined sequence, or it is a finite sequence. That is why my region of convergence is the modulus of z is less than infinite, right? Like it states over here, except z is equal to 0. Entire z plane except for z is equal to infinite, right? So basically everything for z is less than infinite, because there is no value greater than infinite, right? Isn't it? So that becomes my region of convergence for this particular term. So combining these two, right? Combining these two, so the overall region of convergence for this whole term will be R1 is less than Z, right? Based on this particular term, and absolute of Z is less than infinity, right? So this becomes my region of convergence for this particular part, right? Next is for the left-hand side sequence. So let's say a left-hand side sequence. So in a left-hand side sequence, basically, a left-hand side sequence is basically majority of the parts will fall on the left-hand side of the plane, isn't it? On this side of the plane. So based on this, again, if n naught, right? We're starting from 0. If you're starting from 0 and it continues on this side, and it doesn't stop, it is an infinite series, right? In that particular case, my region of convergence for this, the region of convergence for this particular side is given by, in this particular case, right? It's an infinite series and it is falling on the negative side. So my region of convergence is the modulus of z is less than some radius r1, right? So in this particular case, we have already defined r1. We have used it for the right hand side sequence. So we'll use r2 to define the radius of this particular sequence, right? So what happens is the region of convergence for this particular term over here is that the modulus of z is less than some radius r2, right? What happens if your sequence, right? What happens now The other case could be if your n naught is not, if your n naught does not start on this side, right? If your n naught is not less than equal to 0, what happens in that particular case? Your system does not start on this side, right? What happens when that's in that particular case? Let's say if your system starts from here, what if n naught is greater than 0, right? In that particular case, you can see the sequence starts from here and it continues to negative infinity, right? Based on the definition we have already written, or the assumption we have already made. In that particular case, the sequence from here till here, that is from negative infinity till, from n is equal to 0, and if it goes up till n is equal to negative infinity, in that particular case, the region of convergence for that will be again the modulus of z is less than some radius r2, right? But what is the region of convergence for this particular term from here till here? In that particular case, this particular sequence is a finite sequence, right? Isn't it? A finite right-hand sequence, isn't it? So in that particular case, we go back to the particular table that I showed you earlier. We're going back to the table over here. In that particular case, right, the region has all the values except for z is equal to 0, right? Isn't it? The region of convergence has all the values of z except for 0. So that is how we come to this conclusion that for this particular term, where n naught is some value that starts on the right hand side of the plane, right? For that particular case, it will converge or for all z values which is greater than 0, right? That's how we get this convergence part. Based on that, combining these two regions of convergence, we get the overall region of convergence for this particular equation. That is, 0 is less than the modulus of z, which is less than the modulus of r2, right? Basically, this sequence is a anti-causal system, right? See the overall sequence, the overall convergence of this sequence. It is basically x of f of z is equal to, right, x of f of n z of negative n, the summation of that from negative infinity to infinity. Again, this is what we have, right? So what happens? We have the region of convergence of 1 and 2. We combine that, so we end up with absolute of z is less than infinity and 2 converges for all z is greater than 0, right? Combining this region of convergence over here and here, this is what we get, right? Thus, the region of convergence is 0 is less than the absolute value of z, which is less than infinity, right? So that's how we get the overall region of convergence for this, right? You can have a total read of this particular part, right? This equation. All the steps are given over here. Okay. I'll end the session over here. I want you guys to rejoin using the same link, right? Is that fine? Because we are running out of time. So we'll need to extend this part into the second session. Okay. I'll end this session. I want you guys to rejoin. Is that fine? Okay. Okay, great. So let me quickly end this session.